Alright guys, let's take a look at these notes on looking at domain and range, some other features of functions, and we use interval notation for these ones. So remember, with interval notation, it's based off the x value. In the case of the range, that's the only one with the y value. But it's based off that x value, and it's simply telling us the area where the domain is, or where it's positive or negative or increasing or decreasing. And behavior and rate of change are different things. Now, the four we really need to make sure we understand is domain and range and increasing and decreasing. These other ones are extras, which I'm going to do in this video, but aren't as important for us at this point. So the domain, remember, the domain is all the x values of our graph. So basically, how far to the left, how far to the right. So we start out, our graph starts out here at -8, and it keeps going to +8. That's the domain of our graph, -8 to +8. Okay? The range is the y values. So how low does it go, how high does it go? Well, it starts, the lowest point is at -2, goes up to +9. So from -2 to +9. Okay. Now for positive and negative, positive is simply where it's above the x-axis. So if we'll notice here, we've actually got two sections where it's above the x-axis. Right here and right here. So from -8 to -4, it's positive. Then we jump, and so we have to put a little u at -1 to +8. So from -1 to +8. So it's negative just in this small section. So it'd be from -4 to -1. Okay? So the end behavior is simply what happens as we go to the right or to the left. So as we go to the right, we get to the number 9. So as I go to the right, it approaches or gets to 9. As I go to the left, it gets to the y value of 8. So I can write it like that for now. Okay. Now, increasing or decreasing. Okay. So increasing is where it's going up as we look left to right. So it'd be that section right there. So from the x value of -3 to the x value of 8, it would be increasing. Decreasing is simply where it's going down. So it's decreasing at this section. So from -8 to -3. And for the rate of change, because it's not a linear function, we'd have to pick some points. So we'd say from -6 to +4. So -6, it's right there. +4, it's right here. So we find the slope. We'd go up 2 to the right, 6, and 4, so 10. So in this case, it'd be 2 over 10, which would be 1 over 5. But depending on which points you choose for rate of change, it's gonna determine which ones are different or not. Okay. So, but again, when it comes down to it, okay, positive, negative end behavior, and rate of change, we don't care as much as these two sets. Okay. All right. Second graph. So our domain here. Well, the furthest left we go is -4, and then my graph exists until 0. Then we take a jump, right? And we start again at 1 to 3, and then jump again from 4 to 5. So I have 3 sections in my domain. So -4 to 0, then we jump, then 1 to 3, then we jump again, and 4 to 5. Okay? For our range, the lowest point we go is -4. And then my graph exists until we get to 2. So -4 to 2 for our range. Okay. Where's this graph positive? Well, really from that section up here, right? So it would be from probably 4.5 to 5. Which means everywhere else, it's going to be negative, isn't it? All these sections right here. So from -4 to 0, then from 1 to 3, and then finally from 4 to 4.5. Okay, our end behavior, as it goes to the right, what is it getting to? Well, looks like it's getting up to 2. As it goes left, what is it getting to? Down to -4. Okay, now where is this increasing? So we're increasing this section and this section. So that'd be like those two sections, wouldn't it? So from -4 to 0, and then from 4 to 5. Where's it decreasing? Okay, it'd be this one section, that one right there. So 1 to 3. And then for the rate of change, again, we'd have to pick 2 points. So let's go from this bottom to the highest. How about from -4 to +5? So we'd go up 1, 2, 3, 4, 5, 6. To the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 6 over 9, which would reduce to 2 over 3. Okay. All right, so there's those ones. Okay, number 5, same idea. Our domain. Now notice this arrow means it's going to keep going to the right and up. So we start here at -6. But now I'm going to keep going off of my graph. Well, as we go to the right continuously, we call that infinity. So my domain is -6 to infinity. Okay, my range, my lowest point here is at -3, but it's also going to keep going up to positive infinity, so -3 to positive infinity. Okay. Now, where's my graph positive? From -6 to -4. And then it becomes negative at -4, right? Negative until we get to +4. Then it jumps up to be positive again and goes off into infinity. Okay. So in behavior, as it goes to the right, what are we doing? Well, we keep going up to positive infinity. As it goes to the left, we get to 3. Okay, when is this increasing? Well, we've got a few sections, don't we? Increasing from here to here, increasing from there. So where's it decreasing? This section and this section. So decreasing, we'd start at -6 till we got to -2. Then it increases from -2 to +2. Then we're back to decreasing from 2 to 3. And finally, we finish with increasing from 3 to infinity. Okay, rate of change. Well, let's say we chose this section from this point to this point. Then it would be the slope of that section, right? So we go up 2, to the right 4, so 2 over 4, or 1 over 2, 1/2. All right, so there's with our graphs. Okay, now with tables, still the same idea. So our domain is all these x values. Okay. Now, technically, we should probably just write them all in, but I'm okay if we just write from the lowest number to the highest number is our domain. Our range is from this lowest to the highest. So, but 5 isn't the lowest number. We should recognize that 0 is the lowest and 6 is the highest, so it would be 0 to 6. Okay. Now, when I look for positive, I'm looking at those y values. When are those y values positive? They're positive the whole time, so from -4 to 2. When are they negative? Never, so I can either write never, or I can do what we call the empty set, and just brackets without anything inside. Okay? End behavior, as we go to the left the most, looks like it's going to hit 5. And as we go to the right, it's going to hit 6. Okay. Rate of change, again, we'd have to pick from one point to another. Let's go from -3 to 1. So -3 to 1 would be 4. 4 to 4 would be 0. 0 over 4. would give us a rate of change of 0. Okay, which can happen depending on which ones we choose. Now finally, when is this increasing? Well, here we look at the y values and we determine when is it going down or when is it going up. So we'll do them together. So 5 to 4 we're decreasing, 4 to 3 decreasing, 3 to 0 decreasing, 0 to 3 now we're increasing, 3 to 4 increase, 4 to 6 increase. But remember, we're using the x values to judge. So I would go, it's decreasing from -4 to -1, meaning it's increasing from -1 to 2. Okay? Alright. Let's do the same thing now. Domain. It's all these guys. So -1, 0, 1, 2, 3, 4, 5, and 6. Our range, highest is 25, lowest is -10. -10 to 25. Positive, well, 25 to 0 is positive, so -1 to 4. Which would mean negative goes from 4 to 6, because those are when we get negative. Okay, when would this be increasing? Well, 25 to 20 to 15, it's always decreasing, so that would be empty. So decreasing would be from -1 to 6. Okay, then our end behavior, as we go to the left, gets to 25. As we go to the right, gets to -10. And rate of change, let's go from -1 to 6. So that would be 7, right? 25 to -10 would be 35. So 7, and it's going down, so it would be a -35. So -35 over 7, which would be a rate of change of -5. Okay, our last one, our domain. Again, all the x's. Notice that it's a little out of order. So to put it back in order, we'd actually change the 3 to a 1, which would mean that would be 31. And change that 1 to a 3, which would make it 28. So from -1 to 3 is our domain, and everything in between. Our range, our highest is 20, never mind. Our highest is 31, our lowest is 20, so we'd go from 20 to 31. Okay. When is it positive? Well, they're all positive numbers, so it's always positive, so from -1 to 3. Right? Because that should have been 3. Okay. So it's never negative. And behavior, as we go left, we get to 25. As we go right, we get to 28. When is it increasing? Well, 25 to 20 decrease. Oh, then we increase, 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 decrease, decrease. So we're increasing from -2 to 1. We're decreasing from -1 to -2. Then we jump, and we go from 1 to 3. Finally, rate of change. Well, we just pick a few. Let's go, what if we went 2 to 3? Well, that would -2 to -3. Uh-oh. Made a mistake, too. That -3 needed to be bumped up, huh? So that should have been -3, actually. Which would have changed a lot of stuff, wouldn't it? That's why we got to pay attention to those, don't we? So -3, -1, 22, 25. So, and behavior would have been different too, yep. One and 3, 31, 28. Alright, so let's try this again. So left would actually be getting to 22. right would still be getting to 28. Okay, increasing, now we start out by decreasing, then increasing, then decreasing. So did it change that at all? No, it was still the same, I guess. So increasing was still from -2 to 1. So decreasing would have been from -3 to -2, then from 1 to 3. And rate of change, if we pick these two, this is going up by 1, this is going up by 5, so 5 over 1, or just 5. Alright, there we go, guys. There's some notes. Hopefully that helped you understand a little bit better how to find domain range, increasing and decreasing, and all the rest.